Welcome to Research Revealed, where we spotlight innovative research happening right here at the Computer Science and Engineering Department at UTA. This month, we're featuring Dr. Allison Sullivan, who recently received a $400,000 National Science Foundation grant for her project.
I am working on this grant to build Model by Numbers, an interactive educational tool for formal methods. It was inspired by the concept of paint by numbers, where it tells you to put this color here. So the whole tool is based off of a series of exercises that take you from a concrete interaction with the model to the abstract you need to actually write it yourself. So it'll have things like drag and drop interfaces where you can try out different formulas and plug and chug and go from there.
A software model is like a blueprint for a computer system. It shows how a system should behave using precise mathematical logic.
So in general, people are really bad at writing software systems correctly. And as we rely on them more and more in our daily lives, there's just a growing need to make sure they're actually correct. One way we can do that is by using software models, so you can outline the expected behavior of your system.
The challenge is that learning these modeling languages can be tough. That's why Dr. Sullivan is developing an interactive educational tool that automatically creates practice exercises and provides real-time feedback when learners make mistakes. This approach makes modeling more engaging and accessible, helping more students and professionals build confidence with complex systems.
When I was starting my PhD, my advisor was like, "Oh, you don't know what you want to work on exactly. Here's this modeling language called Alloy that you can explore," and he was excited to have someone open to projects. So I started using it, and it was extremely frustrating to use as a tool. And I had no idea if I could tell if my model was actually correct after I wrote it, and I found it a really frustrating process. All the research I've worked on since has been about trying to make that learning curve not feel so miserable, because it was so miserable for me.
By simplifying how people learn software modeling, this research could expand the number of engineers who can design error-free, dependable software, directly impacting industries where safety is critical.
Almost everything we use in our daily lives now involves software, and more things are just critical to us for them to work correctly, like your banking application. You don't want to go wrong and then, because most of us, our interaction with our bank account is on a screen where the number we have is rendered, and we want that to be as accurate as possible and never go wrong. So as more and more things become systems we depend on, they just need to be correct. And I really believe software models can get us there if the average developer can actually use them.
At UTA's Department of Computer Science and Engineering, faculty like Dr. Sullivan are turning bold ideas into real-world solutions, making software smarter, systems safer, and education more accessible.